Hello and welcome to this installation of our plant engineering video conversation. I'm Amara Razgas, Editor-in-Chief of Plant Engineering, and today I have connected with Dr. Neil Canter to talk about trends in lubrication. Thanks for joining me, Neil.
Thank you.
Yeah, and here's some background about my guest. Dr. Neil Canter runs his own consulting company, Chemical Solutions. He specializes in commercial development, marketing, product development, and regulatory support for the lubricant industry. Neil provides support to the STLE as the STLE Tech Advisor. He's also a member of the American Chemistry Council and SAE. Today, we will be talking about the 2026 STLE Emerging Trends Report, which was recently released. It highlights 4 key pillars shaping the future of tribology and lubrication engineering: artificial intelligence, advanced manufacturing, thermal management, and decarbonization. These trends emphasize a shift towards smarter, sustainable, and specialized lubricants. So just to kind of set the stage here, Neil, of all the trends covered in this report, which one do you believe will have the greatest impact on the field over the next 2 years, and why?
I think the one pillar that will have the greatest impact without question is artificial intelligence. Artificial intelligence, which is a relatively new technology, I think at this point it's only been 3 to 4 years old, has already started to have enormous influence over our society. And for us in the tribology and lubrication field, it is starting to pick up significance, as noted in the trends report, in areas like R&D and manufacturing, both areas where there is need for it to be done properly to help improve our ability in R&D first to develop better products, reduce our product development cycle, collaborate more, as noted in the report, communicate better, which we need to do amongst ourselves in the field and communicate with those on the outside so better understand what we're doing. And then from a manufacturing sector, with manufacturing being such a challenging thing and even more challenging these days, it can help us in a variety of ways to improve productivity, efficiency, save energy, and even reduce emissions.
Okay. Okay. So, Neil, this report discusses thermal management, the advances in thermal management. What new demands are coming from electric vehicles, power electronics, high performing computing systems? I mean, there are so many demands.
And that's right. There's so many demands, Amara. I think the idea here is that electrification, which is going on as we move forward here, electric vehicles, data centers, which you had mentioned, and other aspects. All these areas where electronics are involved under high temperature, pressure applications generate a lot of heat. Heat is being generated, and lubricants are being looked at more and more for thermal management. Lubricants already, as noted in the trends report, have been used widely and continue to be used widely in thermal management. We call it heat dissipation, reducing heat generated, because heat will do a number of things. It will, if there's heat is left unchecked, it increases friction and wear. It reduces, say, in metalworking fluids, the ability in metalworking operations, the ability of the tooling to operate effectively, and tooling can be expensive for end users. So already thermal management has been done by lubricants. What we tried to do in the trends report is to highlight the fact that with electrification, thermal management is becoming even a bigger focus point for those of us in the industry in trying to figure out ways to dissipate heat, to improve electronics, and improve the quality and efficiency of machinery.
Okay, so let me continue that thought a little bit, Neil. In your view, what are the most promising lubrication and surface engineering strategies for managing that heat more effectively, like in next generation systems?
Well, what's come to pass, particularly in things like data centers and even electric vehicles, is that air cooling and water cooling is not satisfactory. It doesn't provide a sufficient amount of thermal management or heat dissipation to keep the electronics cool. In effect, electronics like to operate at room temperature, as we humans do. When it gets too cold or too hot, electronics don't work as well. So at this point, what we see from a lubricant standpoint is the use of newer technologies, which include lower viscosity type of synthetic base stocks to be used with the proper additive components to provide thermal dissipation, as long as they can be compatible with the other components in an electrification system, which can get complicated in a data center or an electric vehicle or even a storage facility run by batteries. These are all areas where there can be a number of different things going on. And to provide cooling and to stay compatible, newer lubricant products are being developed as we speak, and the industry is working to develop new ways to evaluate them so to provide the effectiveness that these industries need moving forward.
Okay, yeah, good point. So, what do you see as the biggest technical challenge or commercial barrier, maybe, to wider adoption of these fossil-free or more sustainable lubricants?
Well, I think a lot of this has to do with the fact that we in the lubricant industry are risk adverse. We do a lot of testing, a lot of evaluation of lubricants deliberately because we know full well that if a lubricant is not properly put into a car, an airplane, a train, or any industrial application, that particular piece of machinery could fail and may very well fail if it's not properly. So we do a tremendous amount of testing to verify the ability of lubricants to be used in those types of applications. So the challenge is much of those lubricants are fossil fuel based, if you will, from crude oil for a variety of ways into base oils as well as petrochemically based to give us the base oil and additives we've been accustomed to using. Moving into a fossil fuel type environment will be challenging for us. We have a number of ways of doing it. And I think the current geopolitics of the Iranian war with the U.S. right now is leading us down a path where we may have to go away from fossil fuel in order to provide these types of approaches. So I think there's motivation now to do more with the renewable type side than there has been, unfortunately, because of what's been going on right now currently in the world.
Right, yeah, a lot of motivation. So then how should engineers evaluate those trade-offs between sustainability, cost, durability, performance when selecting those lubricants? What does that look like?
What that looks like is something that we're used to doing in the lubricant tribology lubrication field, and that is looking at compromise. There has to be compromises made, and the way to do it, as we have found, is by application. A lot of this is application dependent. We talk about it all the time, and each application can be unique. In fact, I would argue in certain applications, looking at one machine versus another, they may be identical, but one machine may behave differently than another machine with the same lubricant. So it depends on the particular system involved. So we need to look at it from a system standpoint, see where the lubricant can be used, see if something that is more renewable can be used, evaluate it, have it tested to move forward, and that has to be done. Yeah, whether it's a wind turbine or whether it's a battery electric vehicle, as opposed to an internal combustion engine vehicle. So all those things have to be done specifically, and we're developing products in those areas to make it happen.
Yeah, that's a really good point, Neil. I mean, talking about cross-disciplinary collaborations, what role do those collaborations play? Like in data science, material science, mechanical engineering, like how do they solve challenges?
Well, they're solved because, and we're used to this in the tribology lubrication field because we work in as I call it, a heterogeneous field. There is not one type of person who becomes a tribologist. We're a mixture, if you will, and I'm a chemist, so I'm using these terms, a mixture of chemists like me, engineers of all types, chemical, mechanical, materials engineers, physicists and other technical people, along with sales and marketing people. So we all have a stake in this, but we come from different perspectives, which from my standpoint is a strength for the lubrication and tribology field. We have a diverse group, and we're used to working with people from different backgrounds, which is what we have to do when we go out to try to solve problems or develop new products for a certain application. We work with people with different backgrounds and try to reach compromises and try to reach a point where we can have a mutual understanding of how our products can work in specific applications.
Okay. Okay. Well, that brings me kind of to a really good question. Looking at the future, if you were advising a young engineer looking at the field today, what areas of expertise would you tell them to focus on, like if they're trying to stay relevant for the next decade?
Well, that's always a difficult question, particularly in these challenging areas. And we know that as STLE is working very hard to help our newer professionals who are getting involved in this area to find traction, if you will, and figure out a path forward from that standpoint. My advice is to learn as much as you can from your discipline and adjoining disciplines to be relevant in looking at trends. Do your research, but then look to see what's out there in terms of trends that as those that we've outlined in the trends report, looking at thermal management, looking at electrification, even as we talked about decarbonization, which is moving away from fossil fuel type things, knowing full well that with artificial intelligence, this is an area where most new people can tap into to work and help expand their horizons in terms of what opportunities are out there. So the idea here is to take a base of knowledge which they may have from their academic experience or their professional experience as part of a new member of an organization and build upon that by doing various things, by going to conferences, by attending and participating in webinars. STLE has an industrial insight program and working on all these aspects to try to broaden their horizons, get visibility through areas like LinkedIn and other sites to find new opportunities and see where they can grow and develop as professionals.
All great points. Thank you so much, Neil. It was great to chat with you.
Thank you.
Yeah, that was Dr. Neil Canter talking about the 2026 STLE Emerging Trends Report, among other topics. For more information on grease, oils, and lubrication topics, visit Plant Engineering at www.plantengineering.com. Thank you so much for joining us, and we'll see you again soon. Bye-bye.